we're going to look at the washer method. The washer method pretty much what it tells us is we'll have two functions in a given bound. And when we rotate it, we're going to have an opening in the middle. There's the axis. So the volume of a washer the area in question, dx. So now what we have the outer washer minus the inner washer. And we have to look at those individually. So this is the formula we'll be using now. So the first thing you have to do is determine which one's the higher or the outermost washer, and then subtract the innermost from it. So example 9 says, the region bounded by the curve y equals x squared plus 1 and the line y equals negative x plus 3. Is revolved about the x-axis. To generate a solid. Find the volume. So what's our first step? Graph it. So the first function, y equals x squared plus 1. What is that graph going to look like? You only have two more, yeah. Yes, because there is no horizontal movement because x doesn't change. So all we do is take the x squared and raise it 1. So the y-intercept is going to be at 1. So at 1, it equals 2. At negative 1, it equals 2. At 2, it equals 3. And at negative 2, it equals 3. So there's that graph. Then the line negative x plus 3. What do we know about that line? It's a linear equation because it's a line. Where's the y-intercept? The y-intercept is always the constant at 3. What's the slope of that line? Yeah, it's negative 1, which is negative. So we go down 1 over 1, down 1 over 1. And it crosses at 3. Okay, so now we have our two functions. We're going to revolve it around the x-axis. So we have so this is the graph part that we're going to be rotating. It looks like a donut. So we're taking this wedge and rotating it around. I'm horrible at drawing 3D pictures. All right, so now we're going to find the volume. What are our bounds of integration? From where to where? Actually, since it doesn't specify, we can go all the way up here. Our bound of integration could be this big picture right here. Since it doesn't specify only in the first quadrant, where is this intercept? We know this one here is at 1, 2. Where's that intercept? Where do the two graphs cross? Well, the way we do that is we set both lines equal to each other. So we have x squared plus 1 equals negative x plus 3. Move both of these numbers over there. So it's x squared plus x minus 2. Now we can factor it. The signs are opposite, and the bigger number gets the plus. What times what is 2? When you subtract them, you get 1. 2 times 1. So our x-intercepts are at -2 and +1. There's at -2. Why do they use letters R for these two? Okay, so since we know our volume is going to be from -2 to 1, our formula says capital R squared minus little r squared. What does the R represent? What does it usually represent when we draw pictures? Remember, we're rotating around the x-axis. Radius. Yeah, so this is the outer radius minus the inner radius. So it's gonna be this at this point minus this point. And it changes throughout the entire interval. So what's the outer function? What's the outer radius? What's the equation of this outer line? Negative x plus 3. So it's negative x plus 3 squared minus, what's the inner radius? Yeah, x squared plus 1 squared. And we're rotating around the x-axis, so it's dx. So the first thing we can do is remove the pi because it's a constant. We can expand both of these because they're Euler techniques. Negative x is x squared. Negative 3x is negative 6x plus 9 minus x squared is x to the 4th plus 2x plus 1. So to go further, take it to the next step. Actually, I'll pause it here. Yeah, so I was looking back here. This middle one should be an x squared also, because the terms are squared. So it's x to the 4th plus 2x squared plus 1. So what do you do next? Get rid of the parentheses. Yeah, combine like terms, get rid of the parentheses. So just x squared minus 6x plus 9. Distribute that. So it's negative x to the 4th, negative 2x squared, negative 1. So I got rid of the parentheses, distribute that negative. Now combine like terms. I have a negative x to the 4th. X squared minus 2x is minus x squared. Minus 6x. 9 minus 1 is a positive 8. Now we can integrate each one of these separately. So we have negative x to the 5th over 5. Negative x cubed over 3. Negative 6x squared over 2 plus 8x from negative 2 to 1. So we put a 1 in front of all those x's. So we have -1 to the 5th over 5 minus 1 cubed over 3 minus 6 times 1 squared over 2, 8 times 1 minus -2 to the 5th over 5, -2 cubed over 3 hopefully you're comfortable enough to at least get this far. So -1 to the 5th is -1 over 5 minus 1 over 3 minus 6 over 2 plus 8 -2 to the 5th, 2, 4, 8 is -32 over 5. -2 cubed is -8. Negative and negative makes it a positive 12 over 2 minus 16. Plus 3 plus 8. 32 over 5 plus 8 over 3 plus 6 minus 16. It's 5. Again, hopefully y'all know how to plug in these and do the algebra part itself. Because I'm not going to spend much time explaining that part. Because the rest of this stuff is algebra. You guys should know algebra by this point. I can remove the parentheses. -1 over 5 minus 32 is -33 over 5. -1/3 minus is -9 over 3 plus 15. Nine over 3 is 3 plus 15. 15 minus 3 is 12. Five is the common denominator. So -33 plus 60 is 27/5 times pi. Now go back and check, make sure I did everything correctly. Hmm. 6/8 minus -2^5. I changed the number. This one should have been squared. This is 6x², 6x². So it should have been +4 times 6 is 24, so it's -24/2, which means it's a -12, which makes this a -26. Always check your work. Or 28. That had been 28. It should have been -23. Should have been -69. No, positive. That was +20. +33. So it's -3 plus 33 is a +30. So times 5 is 150. So it's 150 minus 33 is +117/5. So the answer is 117 pi/5. I forgot to square the -2. And you all didn't catch that.
Done, no, that was really.
See?
I just didn't think to look up to see that he comes.
And this is the worst part, because The stuff is simple. This is all algebra now. It's just forgetting to put something. Usually it's a negative sign, but this one here is I forgot to square it. So you gotta always go back and recheck everything you do. Ready to do number 10? Now, in number 10, the last one, it says, the region bounded by the parabola y equals x squared and the line y equals 2x in the first quadrant is revolved around the y-axis and to generate a solid. Whoa. So, the region bounded by y equals x squared and y equals 2x in the first quadrant is revolved about the y-axis. Find the volume of the solid. So as always, we drop, since we're only looking at the first quadrant, y equals x squared. That's a parabola. The line y equals 2x. At 1, it's 2. At 2, it's 4. Okay, so we drew the graph. Now what do we do? So what good is that graph going to do for us? We can't find the volume until we know the bounds of integration. Which way are we rotating it? About the y-axis, so we're going this way. So we're just taking this solid here and rotating it around the y-axis. So what does that mean? Well, our bounds of integration, we can't do anything yet because our bounds of integration will be where the two lines intersect. We have y equals x squared and y equals 2x. But that's if it's rotating around the x-axis. We have to solve for x. We need a function with respect to y, because we're rotating about the y-axis. So here we square root both sides. So x is equal to plus or minus square root of y. And here we have x equals y divided by 2. Since we're looking at the first quadrant, we only want the positive y. Okay, so that's important because now we're rotating with the y-axis. What do we do with both of these equations? So this is our first step. solve for x. Because we want x to be a function of y. Step 2. Set x1 equal to x2 to find where they intersect or where they cross each other. Because that's going to be our bounds of integration. So x1 equals x2, square root of y equals y over 2. We know they're going to be equal at 0. X is 0, they're both equal 0. If I square both sides, I get y equals y squared over 4. Multiply both sides by 4. So we have y squared equals 4y. Move that over. So y equals 0 and y equals 4. These are our bounds of integration. So now what do we do? Our third step is we have to figure out what formula we're going to use. Since we're doing it along the y-axis, we have CD pi r of y squared minus r of y squared dy. We know what C and D are. C and D are the bounds of integration, where they cross, where they intersect each other. So it goes from 0 to 4. Now we got to figure which one's the bigger radius, which one's the smaller radius. Let's look at these. Out of these two, which one's the outer radius? Why? Well, isn't it whoever's on top? No, I confused you there. Because if we were rotating around the x-axis, then it's this way. Then this would be the outer one. This would be the inner one. But since we're rotating around the y-axis, this is the outer one. So it's x equals the square root of y. And the inner one, this is The inner one is x equals y over 2, the linear equation. Because we're rotating about the y-axis, not the x-axis this time. So we have the square root of y squared minus y over 2 squared dy. Square root of y squared becomes what? Right? Y over 2 squared becomes y squared over 4. Pick out the pi. Actually, we can go ahead and integrate both of these as they are already. What's the integral of y? Y squared over 2. Because the power of it is 1 already. Y squared over 4 is the same thing as, so y squared over 4 is the same thing as 1 over 4 y squared. The integral of y squared is what? Y cubed over 3. So we have y cubed over 12. This becomes 4 squared over 2, 4 cubed over 12, minus 0, so that doesn't matter. Sixteen over 2, 64 over 12. Eight. Okay, that simplifies. So 64, yeah, to the next page. Sixteen over 2, 64 over 12. So 64 over 12. 2 goes into there 32 times, 2 goes in there 6. 2 goes in there 16 times, 2 goes in there 3. multiplied by 3, so we got 24 over 3, 16 over 3. So we have 8 over 3 pi. That's the last one. Difficulty level. Out of the 3 methods, which one's the easiest? Washer, disc, or slicing? This one is more applicable because you won't always have the function right off the x-axis. So this one is a lot more applicable. But the hardest part about this one is making sure you know which axis you're rotating about, so you know which one's capital R, which is minuscule r. And it's also better because we just did this one. We forgot we've had a 3-day weekend and we've got the last one. All right.